get it warmed up. Hey, look at that. It actually is working today. All right, so it's Thursday, and it's day 2 of our topic or section 3.4. So let's do a little warm up. You should have watched a video yesterday about factoring. And so I'm going to give you a couple of minutes here to completely factor this expression, 8x to the 4th minus 18x squared. Okay, so I'll give you a couple of minutes. Those of you watching on the video after the fact, pause and then hit play when you're done. All right, so hopefully now things will be back working. And we're good. All right, here we go. So first thing we look at GCF. Why didn't it kick on? Come on, kick on for me. There it goes. Just a little slow today. Okay. First thing we look at is we look for a GCF between 8 and 18. Both can be divided by 2, so I can factor out a 2 for sure. X to the 4th and x squared, I can factor out an x squared. So then that would leave me with 4x squared minus 9. Now I've got to look at that 4x squared minus 9, and I've got to say to myself, can that be factored? Well, first thing that comes to my mind is we have a subtraction sign there. 4 is a perfect square, it's 2 times 2. X squared is a perfect square, so it's x times x, so that means that this is 2x times 2x. 9 is a perfect square, so we've got the difference there of perfect squares. So this would end up being factored completely, 2x squared times the quantity 2x minus 3 times the quantity 2x plus 3. And that, ladies and gentlemen, is the fully factored completely form. Okay? Thumbs up, good. Thumbs to the side, and we maybe stopped at the green, but we didn't go all the way to the end. Thumbs down, we got it totally wrong. Good. Lots of thumbs up. Love it. Okay? All right? So what we're going to do today is we're going to get into true math today. Love this stuff. Okay? So what we're going to do is we're going to take this, and now instead of it just being an expression, we're going to actually solve these. So we're going to have an equal sign now. We're going to go from an expression to an equation. We're going to still factor, and then we're going to solve it from there. So let's get into that. Okay? The fundamental theorem of algebra says that the degree, we talked about this earlier this week, the degree of the polynomial tells us how many solutions we need to have in the end. So with this particular function this particular equation that we have here, the fundamental theorem of algebra says that the biggest exponent is 5. That's our degree. That means we need to come up with 5 answers. If we don't come up with 5 answers, we will need to keep going until we get them. Now, for the purposes of right now, we're only going to find real answers. Well, later on in November, so because next week is only a 2.5-day week next week. So when we come back after that, then we'll talk about imaginary solutions, and then that will allow us to find all of the solutions. Okay? But for today, we only need to find the real ones. Okay? So first thing that you should do, I'm a step kind of a guy. So the first thing that you should do is you should get it equal to 0. And I don't care if you get it equal to 0 or 0 equals, okay? But you need to have it equal to 0 at some point in time, okay? So in this particular case, I would move the 36x to the left side. So that's going to be 4x to the 5th minus 40x cubed plus 36x equals 0. And you want to write that in standard form. Biggest exponent first, then the next biggest, then the next biggest, and so on and so forth until you get all the way down to the constants. Okay? So that's step number 1. We got it equal to 0. Step number 2. We are going to factor completely. We're going to factor until we can't factor anymore. Okay? So first thing that I'm looking at here is I would notice that I can pull out a 4 from 4, 40, and 36. All of those are divisible by 4. And I can pull out 1x from all of them. If I do that, I'm left with x to the 4th power minus 10x squared plus 9. And that is still equal to 0. Okay. Now I got to look at that orange trinomial, and I say to myself, I think that that's factorable because I need two numbers that multiply together to be 9 and add to be negative 10. Well, that can be, let's see, I started with the purple, 4x, going to it. We'll really rainbowify the colors. We'll go red here. 4x, and then we're going to break this up into 2 parts. And that's going to be x squared minus 1 and x squared minus 9. Still equal to 0. Okay? Because then when I do that check, I've got negative x squared. I've got negative 9x squared. That's negative 10x squared. That's exactly what I want. So we factored that trinomial completely. Shaboom. Oh, but now what do I see in the red? Both of those are perfect square minus perfect squares. So this ends up being all in the final fully factored stage, 4x times x minus 1 times x plus 1 times x minus 3 times x plus 3 equaling 0. So we've factored that completely. We got to factor until we can't factor anymore. And now we set up some mini equations. I call them mini equations, but you set each factor equal to 0, and you solve from there. So this would be 4x equals 0, x minus 1 equals 0, x plus 1 equals 0, x minus 3 equals 0, and x plus 3 equals 0. So you would get x equals 0, x equals 1, x equals negative 1, x equals 3, and x equals negative 3. Remember how I said we needed 5 answers? 1, 2, 3, 4, 5. We got 5 answers. Yahoo for school. Okay? Now, ideally, we would go back and we would check them in our equation. Okay? 0 is an easy one to check because anything with an x term is going to be zeroed out. So we got 0 minus 0 equals 0. That one checks out. 1 is anything to the 1, or 1 to any power is 1. So this is going to be 4 minus 40 equals negative 36. That's true. -1. -1 to the 5th power is -1, so that's -4. -1 to the 3rd power is -1, so that's -4 plus 40, which is positive 36, which is what negative 36 times -1 is. The first three check out. And I am going to tell you right now, 3 to the 5th power is 243, okay? But it checks out. Same thing with -3, okay? I just don't want to, I'm lazy. I don't want to go to my calculator, okay? So we check them because then we want to know if they're right or not. And then in the final answer, I mean, it would be nice in terms of the final answer if you wrote them all in numerical order. So I mean, so that would be like -3, -1, 0, 1, and 3. That would be cool. Or because we've got positives and negatives, we could go 0 plus or minus 1 plus or minus 3. Because let's be honest, it's all about making me happy, and the easier that I can read your answers, the easier it is, the faster I can check things, the faster I can get stuff back to you. Okay? All right? Okay, all right. All right? Okay? So, with that being said, and those 4 wonderful steps being done, at this time, what I would like you to do is I would like you to solve and find me the 4 solutions to this particular one. Go for it. It's not. Usually it freezes me. There it goes. Now it's frozen. There. Now we're all right. Here we go. So first step, we got to get it equal to 0. So I am going to add 3x squared to both sides. That's going to give me x to the 4th power plus 3x squared minus 10 equaling 0. Factor it. So this can be factored to x squared plus 5 and x squared minus 2 equals 0. Because then I get 5x squared off of these two, and I get negative 2x squared off those two, which together gives me 3x squared in the middle, which I need. Neither one of those are perfect squares minus a perfect square, so we're technically done with the factoring there. So now we say x squared plus 5 equals 0, and we say x squared minus 2 equals 0. So we can then solve those. So I could subtract here 5, and that's going to give me x squared equals negative 5. And that's one of those imaginary cases. So in this case, two imaginary, oops, not imaginary, imaginary. We're going to have two imaginary solutions from that one, but we only asked for real solutions, so we don't have to worry about those at all. Then over here on this one, I'm going to add 2 to both sides, and that's going to give me x squared equals 2. And then I'm going to square root both sides, and when I square root and I'm solving, that means that I have to add the plus or minus. And so we would have plus or minus the square root of 2. And those both check out because we have even exponents. The square root of 2 to the 4th power is actually 4. 4 minus 10 is negative 6. The square root of 2 squared is 2. 2 times negative 3 is negative 6. Both of those check out. So we would have here plus or minus the the square root of 2 as our answers. Okay? Now, we should have 4, right? But 2 of them were imaginary, 2 of them were real, so we kick out the imaginary ones for this week. Next week, or I shouldn't say next week, the week after, we'll bring back imaginaries, and then we would be able to get all 4. Okay? Try this one next. Again, if you're watching the video after the fact, pause, do it, and then come back, and because I'm going to pause the video so you don't have the 90-minute video here. This one is already equal to 0, so we're good there with that. So then we can factor it. 4 terms, 1, 2, 3, 4 terms. That to me says grouping, where I'm going to take these first 2 and I'm going to GCF it. That's going to give me an x squared, leaves me with an x plus 3. Then I'm going to take the second 2, and I'm going to go positive 5, and that's going to leave me with an x plus 3. And then that's still going to be equal to 0. Then I'm going to take this whole thing. Both of them have an x plus 3 in it, so I'm going to factor out an x plus 3. Leaves me with an x squared plus 5. Oh, there's that x squared plus 5 again. Okay. So then I can say x plus 3 equals 0. So x there is going to be negative 3. X plus 5, x squared plus 5 equals 0. X squared equals negative 5. So that's going to be 2 imaginaries again. So those get kicked out. So the only one that I have left is negative 3. So we'd have negative 27 plus 27 is 0. Minus 15 plus 15 when I check it, that gives me 0 equals 0. And so negative 3 is the only real solution to this one. The other 2 of plus or minus I times the square root of 5, those aren't real, so we don't have those as our solutions just yet. Okay? Question of the day today is, what is your favorite board game? What is your favorite board game? We'll type that in the chat, or if you're watching after the fact, send me an email with your favorite board game to clear your absence. Oh yeah. Okay. While you're doing favorite board game, let's do this last one here. Okay. So find me the real solutions to this one. All right, so first, we need to get it equal to 0. Okay? So I'm going to go subtracting 3x squared, subtracting 3x. Minus 3x squared minus 3x. Okay? So that's going to give me 3x cubed minus 3x squared minus 3x equals 0. They all can be divided by 3. So I could factor out a 3. They all have an x term in it, so I can factor out the x. Okay. That's going to leave me with x squared minus x minus 1 there as my trinomial. Okay. Now the downfall of this trinomial is that there are no 2 numbers that multiply together to be negative 1 and also add to be -1. So that is an unfactorable trinomial. So we still continue on with our steps. So we would say 3x equals 0, and we would go x squared minus x minus 1 equals 0. And so we would still get here x equals 0 for one of our solutions. We're good there. But now we got to figure out how we can solve x squared minus x minus 1. And I'm going to possibly bring up a painful memory. Okay? We use what's called the quadratic formula. For those of you that don't remember, that is opposite of b plus or minus the square root of b squared minus 4ac all over 2a. I strongly recommend that you write that down. If f of x equals, actually f breaks, not f of x, if 0 equals ax squared plus bx plus c. Okay. So this would be then x equals, the opposite of b would be +1 plus or minus the square root of -1 squared minus 4 times a is 1 times c is -1 all over 2 times 1. -1 squared is +1. 4 times 1 times -1 is -4, minus a -4 is like +4. 2 times 1 is 2. So we would get here that x then is equal to 1 plus or minus the square root of 5 all over 2. And then we would have to make sure that this radical, the number, the square root there, would be simplified, and we'd have to pull out perfect square factors and so on and so forth. So in the end here, we were asking for 3 answers because our biggest exponent was 3. So the 3 answers that we would give here would be 0 and 1 plus the square root of 5, all divided by 2, and 1 minus the square root of 5, all divided by 2. Now, if you wanted to leave those 2 written like that, I'm totally fine with that. Okay? But just to show you how the breakout works so that we get our 3 total answers, I wrote it out separately right like that. Okay? If there are any questions, comments, or concerns, I'll hang out here in the meet for the next 20 minutes or so. I am still waiting on 54 pieces from last unit, 10 week 4 homeworks, 5 formative assessment 2-1s, 12 week 5s, 5 2-2 formative assessment, 15 week 6s, but the most important one are the 7 people that have to take the test yet. If you are one of those 7 people, you need to get that test done as soon as possible because it is the end of the quarter starting on Wednesday. Okay? This weekend, today at 3 o'clock, I set a timer on the formative assessment. The formative assessment will open today at 3 o'clock. So you have that to do, and you have the week 7. Yep, I had to make sure we're on week 7. The week 7 worksheet can also be done and turned in by Sunday night. Okay? That's all I got for you. Make sure you answered the what's your favorite board game in the chat. Otherwise, have yourselves a great, grand, and wonderful weekend, and get me work if you have any to get me. Have a good weekend.